Recording in progress.
Very good morning. See here, I'm starting the session. Listen. So in the previous session, we discussed about set operators. So to combine the rows from multiple tables, we can use these set operators. So there are set of Oracle SQL is providing 4 set operators: union, union all, intersect, and minus. Yesterday we have seen this example. If branch 1, one shopping mall's branch 1 is maintaining customer details like this. These are the branch 1 customer details. These are branch 2 customer details. If you want to get branch 1 and branch 2 customer details, use union here. If you want to get common customers of branch 1 and branch 2, use intersect. Okay. If you want to get only specific customers of branch 1, customer 1 table, only specific records we want. The customers who are visiting branch 1 only, then use minus. Customer 1 minus customer 2. If you want to get the specific customers of branch 2 only, then customer 2 minus customer 1. So these set operators we discussed in the previous session. Now today's session is important. Pay attention and listen carefully here. So topic name is giants. Giants, this is very, very important for the interview as well as for real-time work also. This topic is very, very important. So many students got job with this topic because most of the students feel giants is the tough topic. So interviewer focuses on this topic. If you have knowledge on this topic, it will be plus for you. See, listen. So company maintains the database. Database means more than one table will be there. Database is made up of with multiple tables. For example, if we take college database, college has to maintain student details, their marks details, their fee details, okay, their staff details, their library details, etc. So if we take the database is made up of with multiple tables. Okay. So one college is maintaining database like this. So there is a table, student table is there. In the student table, columns are there like student ID, student name. And student city. This is the structure of student table. So like student table, there is another table is there. Marks table is there. Marks table has fields like SID, marks of subject 1, or math subject marks, physics subject marks, and chemistry subject marks. So like these two tables are there. Student table has student details. Marks table has marks details. Now, maths faculty is asking that he wants student details along with maths marks. Okay, maths faculty is asking, he don't want data of physics, chemistry, all these things. Just he wants maths marks with student details. So what we want now? Student ID, student name, and maths subject marks. So like this we want to get. This is our requirement. So we want to get student ID, student name, and maths subject marks. This is our requirement. Student ID, student name columns are in which table? Student table. Mass marks are in which table? Marks table. Now our requirement is we want to retrieve data from two tables, from multiple tables. So SID, SName, these two columns are in student table, and this mass column is in the marks table. Here student ID, student name, these two columns are in the student table. Mass column is in the marks table. Sorry. So we want to get data from two tables here. From student table, SID, SName we want, and from marks table, mass we want. In such type of situations, to retrieve data from multiple tables, we have to use the concept, GANs concept. That is the purpose of GANs. To retrieve data from multiple tables, we use GANs concept. This is the purpose. Okay. So, for example, tomorrow, principal is asking like he want student details along with math subject, physics subject, and chemistry subject marks. So how we have to retrieve now? Student ID, student name. These are the student details which are in which table? Student table. Okay. And next, in the marks table, math subject, physics subject, chemistry subject marks are there. We want to retrieve like this: math, physics, chemistry. Now, student ID, student name. These columns are in which table? Student table. Maths, physics, chemistry. These are in which table? Marks table. From multiple tables, we want to retrieve now. We have to use which concept? GANs concept. In such type of situations, GANs concept is useful. That is the purpose of GANs. So I'm writing the basic points regarding GAN. Listen. So what is the general meaning of GAN? GAN means combine, connect, link. Okay. So GAN means combine. So GAN means connect or combine. So GAN means connect, or you can say link, or you can say combine. So this is the general meaning. So this GAN concept is used to retrieve the data. It is used to retrieve the data from multiple tables. So GAN concept is used to retrieve the data from multiple tables. Just now I have given example from the student table. Student table is having student details. Marks table is having marks details. We want to get like this: student details and math subject marks, or student details and math, physics, chemistry marks. In such type of situations, to retrieve data from multiple tables, use the concept GANs. That is the purpose of GANs. So GANs concept is used to retrieve the data from multiple tables. Okay. So what is GAN, sir? GAN is an operation, just like sorting operation, just like filtering operation. Salary greater than 3,000 means what? This is filtering operation. Okay. Order by salary, descending order. This is what? Okay. Sorting operation. This is sorting operation. This is filtering operation. Like filtering operation, like sorting operation, GAN is also one operation. Okay. So GAN is an operation that combines. What it will do in this operation, what it will do, that combines one table records with another table records based on one condition. That condition we are calling as the GAN condition. Here GAN condition is important. So GAN condition plays important role here. Okay, my request to you all is, please all of you be before 9:15. Daily I'm starting the session at 9:15. Okay. So topic name is GANs. This GAN concept purpose is retrieving data from multiple tables. If you want to retrieve data from multiple tables, we use this GAN concept. So what is giant? You can say it is one operation like searching up, like filtering operation, like sorting operation. It is one operation. What it will do? That combines one table records with another based on one condition. That condition we are calling as the giant condition. Here, this giant condition is very, very important. Okay, this giant condition decides. This giant condition decides which record in one table, which record in one table should be joined with which record in another table. So giant concept purpose is combining one table record with another table record. Giant purpose is combining one table record with another table record. So which record should be joined with which record? So giant condition decides which record in one table should be joined with which record in another table. Okay. So for example, I'm taking one example here. So with this, you will get clarity on this. Listen, try to understand here. Same example I'm taking, student table and marks table. Student table has fields like student ID, student name, student city. And marks table is having marks details like student ID, math subject marks, physics subject marks, and chemistry subject marks. Okay. So observe here, 1001, some sample data I'm giving. 1001 A, HYD, 1002 B, Delhi, 1003 C, Mumbai, like this I'm giving. So these the students, marks details are there in the marks table. So 1001 student got 70 marks, 90 marks, 80 marks, like this. 1002 student got 56 marks, 78 marks, 45 marks. 1003 student 77 marks, 64 marks, and 81 marks. Like this, some data is there. What is our requirement now? We want to get student details and math subject marks. This is our requirement. Now, SID and SNAME, these two columns are in which table? Student table. And this math marks are in which table? Marks table. So from these two tables, we want to retrieve the data now. Okay. So now observe here, in two tables, which one is the common column here? Student ID is the common column here. So student ID is the common column. Okay. So we have to write giant condition like this. Listen carefully. Giant is one operation that combines one table records with another. One table records will be joined with another, combined, joined with another table records based on one condition. That condition we are calling as the giant condition. Here, giant condition is important. That is performing giant operation. Okay. So in this example, common column is student ID. Now compare student tables, student ID with marks tables, student ID. For student table, I am giving alias name as S, and for marks table, I am giving alias name as M. Okay, in the merge command, we have given alias names for the tables. Like that, here also, I am giving alias names because every time I want to use the table name. Okay, so every time, sometimes table name may be lengthy. So to make table name short, I am giving alias names here. For student table, what is alias name? S. For marks table, what is alias name? M. Okay, so if you want to write the giant condition, we have to write like this. So for example, this student table student ID is matching with the marks table's student ID, then that has to combine. Can we write like this? SID equals to SID. Can we write like this? No. Ambiguity problem will occur. That will get confused. Which SID that has to compare with which SID? We cannot write like this. So that's why to identify this column, we have to use table name. So we write like this. Student dot SID is equals to marks dot SID. Like this we write. But here table, sometimes table name may be lengthy. Okay, so every time writing like this means it becomes complex to us. So that's why to make it short, we are giving alias name here. For student table, we are giving alias name as S. Marks table, we are giving alias name as M. So instead of writing student.sid, simply you can write s.sid. Instead of writing marks.sid, simply you can write m.sid. Okay, so this is called join condition. Based on this condition, it performs the join operation now. That compares student tables, student ID with the marks table, student ID. Is 1001 matching? Is 1001 in the student table? Is it equal to the marks table student ID? That is checking. Is 1001 equals to 1001? Yes. So now this record will be joined with this one. So now this 1001 record will be joined with 1001 record in the marks table. If we join like this, join means what? Combine. We are connecting this record with this record. What is the advantage we will get, sir? If this first record is joined with this record, we can access math marks, physics marks, chemistry marks. So that's why we are performing join operation here. Once again, I'm repeating. Listen. So here we are writing joining condition as S dot. We are writing joining condition as S dot SID is equals to M dot SID. If we write like this, if student tables student ID is equals to the marks table student ID, it will join the records. So this one is called join condition. This is called join condition. So this join condition is deciding which record in one table should be joined with which record in another table. So observe here. Here, 1001. Is it matching with 1001? Yes. So now this first record will be joined with first record in marks table. So now logically, this will be treated as one table now. And from here to here, this will be treated as one record. Because of that reason, we are able to access maths, physics, chemistry marks. If we combine this record with this record, okay, we can access math subject marks, physics subject marks, chemistry subject marks. Our requirement is what? We want to get student details along with math subject marks. So that's why we are combining based on this condition. Here student ID 1001, here also student ID 1001, both are matching. So we are joining. If we join like this, now we can access math subject marks, physics subject marks, chemistry subject marks. Okay. Next, it compares this 1001 value with 1002. 1001, 1002, both are matching or not? No. Student table student ID compares with marks table student ID. So student table student ID 1001, it compares with 1003. Is it matching or not? Not matching. If matching, it performs join operation. If not matching, it will not perform join operation. Okay, next it takes second record. Second value is what? 1002. Is 1002 matching with 1001? No. Is 1002 matching with 1002? Yes. So now it performs the join operation here. So this 1002 record will be joined with this 1002 record. So now you can access this math subject marks, physics subject marks, chemistry subject marks. Okay, 1002 B student, how many marks he got? 56 in the maths. Like this you can access. Next, 1002 will be compared with 1003. Is 1002, 1003 both are matching? No, it will not join. Next, here 1003 is there. Is 1003 matching with 1001? No. Is 1003 matching with 1002? No. Is 1003 matching with 1003? Yes. It performs join operation. Okay. So now 1003 record will be joined with 1003. Now with this, we can access maths, physics, chemistry subject marks. 1003 C student got 77 marks in the maths. So finally, if we specify this column list, after performing join operation, it gives data as 1001 A. Okay, A student in M1, how many marks he got? 70 marks. So now because of this join operation, from here to here, logically, it will be treated as one table. Okay. And from here to here, logically, it will be treated as one row because of join operation. So that's why when you are selecting student ID, student name, it is giving this data. When you are giving mass, it is giving this data. Next, 1002. 1002. Name is B. Okay, how many marks he got? 56. 1003. See, how many marks he got? 77, like this. So finally, we got the output like this. So to retrieve data from multiple tables, we are using the concept, giants concept. Okay. So did you get some idea about giants? Now, listen. Types of giants. So there are different types of giants are there, like equigiant. This equigiant can be also called as inner giant. Equigiant can be also called as inner giant. Next, outer giant. In the outer giant, subtypes are there, like left outer giant, right outer giant, full outer giant. These are the subtypes in the outer giant. Next, non-equigiant is there. Non-equigiant. Next, self-giant. So self-giant. And next one is cross-giant. This cross-giant can be also called as Cartesian giant, or you can say product giant. Product giant, or you can say Cartesian giant. So these are the types of giants. So how many types are there? 5 types are there. First one is equigiant, or you can say inner giant. Second one is outer giant. Third one is non-equigiant. Fourth one is self-giant. Fifth one is cross-giant. This cross-giant can be also called as product giant or Cartesian giant. Okay, in the outer giant, 3 subtypes are there. Those are left outer giant, right outer giant, full outer giant. So among these, mostly we use equigiant. Equigiant is very important here. So among these, mostly we use equigiant. Equigiant is very important. And sometimes equigiant, outer giant also we use, and self-giant also we use. So these are important. Equigiant, outer giant, and self-giant, these 3 are very important among these types of giants. So first one is equigiant. The name itself is giving the meaning here. Equigiant means here, based on equality condition, giant operation will be performed. Just now we discussed one example. Here, student table, student ID. We are comparing with marks table, student ID. Which operator we are using here? Equal to operator. So based on equality condition, if 1001 matching, it is joining. If 1002 matching, it is joining. So based on equality condition, it is performing join operation here. So based on equality condition, if join operation is performed, that is called equigiant. So equigiant means if join operation is performed based on equality condition. Based on equality condition, then it is called equigiant. That's it. So if join operation is performed based on equality condition, then it is called equigiant. So I'm explaining one example on equigiant. Try to understand. Listen, I'm taking one table here. EMP table I'm taking. EMP table has details like employee number, employee name, job, salary, department number, etc. Next, department table has department details like department number, department name, location. So in the Google Classroom, I already uploaded this sample table file. This file is already available, right? Okay. So in this file, department table is there. Observe. Creating department table query is there. And inserting records into the department table also queries are there. So just I want to create this department table and I want to insert 4 records here. So these queries I'm copying. Observe now, I'm opening SQL Plus. See here, our batch schema is C ## Oracle 9 AM narrating. I'm setting page size 200, line size 200, and I'm clearing the screen. If any table is there with the name department, I'm dropping that one. No table is there. Oh, maybe there is table is there, but foreign key established there. So let okay. Okay, see here. Now I'm creating fresh table, department table I'm creating. See here, department table is created. I want to save this table data. What we have tried? Commit. So see the table data here. Select star from department. Observe here. So assume that every department is located in different cities. Okay. So 10th department located in the New York. 20th department research department located in the Dallas. 30th department sales department located in the Chicago. 40th department operations department located in the Boston. Okay. So this is the department data. Now, this data only I'm typing here. So 10th department name is what? Accounts department located in the New York. So 10th department, accounts department located in the New York. Next, 20th department, research department, 20th department, research department. Okay, 30th department, sales department. Next, 40th department, operations department. So like this data is there. So this is the data. Now, I'm giving location values also. Like research department is in Dallas, Chicago, Boston. Chicago, Boston. So this is the data. Okay, so these are the department details. Employee details, I'm taking sample data here, like 1001 A, some salary value and department number. This person is working in 20 department. 1002 person working in 30 department. 1003 person is working in 30 department. Next, 1004 person is working in 10th department. Like this, some data is there. Now observe here. So see, our requirement is we want to get employee details along with department details. That is our requirement. So display employee details, along with department details. This is our requirement. So we want to display employee details along with department details. But observe here in the EMP table, department number is there, but department name is not there. My requirement is I want to get these employee details and his department details also. Department details are there in the department table. Employee details are there in the employee table. From 2 tables, we want to retrieve the data now. Now we have to use Jan's con. So we want to get data like this. Employee name, salary. Okay, is department name and department location. Like this, I want to get. This is our requirement. So if you want to get like this, e-name, salary columns are in which table? EMP table. Department name, location are in which table? Department table. From two tables we want to retrieve now. Which concept we have to use? Jan's concept. So here we write like this. Select what we want. Employee name, comma, salary, comma, department name, comma, location. From which tables we want to retrieve? EMP table. From two tables we want to retrieve. From EMP, comma, department. So here we are giving two table names. Observe here. Then write joining condition here. So we have to perform the join operation now. When this EMP table's department number is equals to the department table's department number, then perform join operation here. So now A employee is working in which department? Research, located in the Dallas. So we have to perform join operation like this. When EMP table's department number is equals to department table's department number. Okay. So that joining condition only we are writing here. EMP dot. So can we write department number equals to department number? No, because here that will get confused. Both columns name is same here. In such type of situations, use table name. EMP dot department number equals to department dot department number. So this one is called the join condition. Based on this join condition, it joins the EMP table records with the department table records and displays the data. So this is equijoin, equal to operator we are using here. Based on equality condition, it is performing the join operation. So this is equijoin. So if we write like this, the same query we can also write like this. Instead of writing like this, it's better to use table name here. So instead of writing like this, here e-name column is in which table? EMP table. So it's better to write EMP dot e-name like this. Okay. So this salary column is in which table? EMP table. So write EMP dot salary. This D name column is in which table? Department table. So department dot D name. Location is in which table? Department table. So department dot location. So now if we write like this, this second one gets executed faster than first one. Why, sir? Why second one gets executed faster? Because here just you are telling that employee name column is in which table? In EMP table or department table? That has to search in both tables here. It takes some time. But whereas in the below query, you are clearly telling e-name column is in the EMP table, select from there. It selects first. Did you get this point? So here, salary means that it has to search for salary column in EMP table and department table. But here, clearly you are telling that salary column is in the EMP table. Okay. Here for department name, it has to search in EMP table and department table. But here clearly you are telling that in the department table, D name is there. So that's why it's better to give table name dot field name. And in this example, for our convenience purpose, we are taking table name as EMP. In the real time, this EMP table name may be like this: employee salary details. Employee salary details. This is the table name. So in such type of situations, what we have to write here? Employee salary details dot e-name, employee salary details dot salary. Okay, here employee salary details dot department number. It is becoming complex. So because of that reason, we are giving alias names for the table. So for the EMP table, I am giving alias name as E. For department table, I am giving alias name as D. Okay. So this here we have no need to use EMP now. We can use E. Here we have no need to use department. We can use D like this. So among all these queries, which one will be executed first? From will be executed. When from is executed, it is identifying the alias names. Those alias names I can use in the where. Then I can use those in the select also. So this is the way. So here we have no need to write EMP here. Just simply write E dot E name. Here also E dot salary. Here also D dot D name. D dot location. D dot location. That's it. Sorry. D dot D name. D dot D name. Okay. E dot E name. E dot salary. D dot D name. D dot location. From EMP E department D, where E dot department number equals to D dot department number. No need to use. No need to use. Okay, just beside of table name only, give alias name. Okay, any short alias name you can give. Okay, no need to use add as keyword here. Don't use as keyword. Okay, so you can write like this, but here, if we are writing like this, it takes some time. It has to search for the column in two tables. But if we write like this, directly it goes to the employee table and picks employee name. Here directly it goes to the department table, picks department name. So second one gets executed faster than first one. I'm showing both. Observe. See here, select. We want to get employee details. So E name. Okay. Listen. So E name. So salary details we want. Salary. Next department details we want. D name. Next department location we want. Location. From which tables we are retrieving? EMP table and department table. Where write the giant condition now. What is the giant condition here? EMP dot department number is equals to department dot department number. Okay, like this we are writing. So observe here, it is displaying employee details along with the department details. Smith is working in which department? Research department. That department located in which city? Dallas city. Observe here. So let me open the table data and you can check. Select star, select E name or employee number. Select employee number, E name, comma department number from EMP. And select star from department. Observe here. See, first employee, Smith is working in which department? 20 department. So 20 department name is what? Research. Observe here. Smith is working in research department. We combined the data. Observe. Okay. Next, Allen and Ward. Allen and Ward are working in 30 department. See. So what is the 30th department name? Sales, Chicago. Okay. Observe here. Allen and Ward are working in. Allen and Ward are working in sales department located in the Chicago. So two table data combined and it is giving. We are getting employee data along with the department details. Is it clear? So, but if we write like this, it takes some time for execution. We are not telling in which table E name is there, salary column is there. So instead of writing like this, we write like this. Select E dot E name. E is the alias name for EMP table. E dot salary. D dot D name. D dot salary. Sorry. D dot location. D dot location. From which table? EMP table E, department table D. For EMP table, we are giving alias name as E. For department table, we are giving alias name as D. Okay. Write the joining condition where E dot department number equals to D dot department number. Observe here, same result we are getting. Observe. Smith is working in research department. Allen and Ward are working in sales department. Okay. So like this, we are getting employee details along with the salary detail, along with the department details. So these are the employee details. These are the department details. Both we are combiningly we are getting. Okay. So what is happening here? Just observe. Which Jan condition we have written for EMP table? What is alias name? For department table, what is alias name? D. Which Jan condition we have written here? E dot department number equals to D dot department number. E dot department number equals to D dot department number we are writing. Okay. So this is the Jan condition. And to say more clearly, this is the equi-Jan because we are using equality condition here. So based on this Jan condition, it is performing the Jan operation here. So now observe here. See, first department number is what? 20. 1001 person is working in 20 department. Is 20 matching with 10? No. Is 20 matching with 20? Yes. It performs Jan operation now. This 1001 A record will be Jan with the 20th department. So 1001 A person is working in which department now? Research. Okay, like this it performs Jan operation. Then again this 20 will be compared with 30, 20, 30 not matching, 20, 40 not matching. It will not perform Jan operation. Next, another employee number it takes. From EMP table, another employee number it is taking. Next employee number is what? 30. Is 30 matching with 10? No. Is 30 matching with 20? No. Is 30 matching with 30? Yes. Performs Jan operation now. This 30 record will be Jan with 30. So with this, the advantage we are getting is we can access department name and location. Now this 1002B person is working in which department? Sales department. Okay, next 1003. Okay, next 30 compares with 40, not matching. Next 30 compares with 10, not matching. 30 not matching with 20, 30, 30 matching. So 1003 will be combined with this 30. Okay, so 1003 person is working in sales. Okay, next this 30 will be compared with 40, not matching. Okay, then next department number is 10. Is 10 matching with 10? Yes, both are matching. It performs Jan operation now. 1004D person is working in which department? Accounts. Okay, next 10 not matching with 20, 30, 40. Next 1005 person is working in 20 department, not matching with 10, matching with 20. Is working in 20 department, means in which department is working? Research. So like this, it performs the Jan operation. Jan means combine. It is combining one table records with another table based on some condition. This condition we are calling as a Jan condition. Now logically, this will be treated as one table. From here to here, this will be treated as one record. Now you can retrieve this data. That's it. Next. Listen. So I want to talk some more points regarding Jans. Listen. A Jan query can be written in two styles. One style we have seen. One more style we have to learn. A Jan query can be written in two styles. What are those two styles? Observe. A Jan query can be written in two styles. What are those two styles? First one is Oracle style. First one is Oracle style, or you can say Oracle style, or you can say native style. Oracle style, or you can say native style. And second style is ANSI style. Second style is ANSI style. Among these, which one is the best way, sir? ANSI style is the best way. So among these, which one is the best way? ANSI style is the best way. Why ANSI style is the best way, sir? Listen. With ANSI style, we will get one feature, portability feature we will get. Okay, say, if anything is following ANSI standard, means that can run on, if any feature is following ANSI standard, means that can run on multiple relational database management softwares. Okay, For example, we are writing one giant query here. Just a minute. So here we are writing one giant query in Oracle. In Oracle, we are writing one giant query. Assume that this is the giant query. The circle is representing the query. So this is the giant query we are writing. This giant query we are writing in Oracle style. In Oracle style, we are writing this one. Okay, now this query, I want to run in SQL Server now. So this is SQL Server, another relational database management software. So if we write giant query in Oracle style and the same query I want to run in SQL Server, so I'm moving from Oracle to SQL Server and I'm trying to run this giant query which is written in the Oracle style. So now if we are moving this giant query which is written in Oracle style to the SQL Server and we are trying to run. So can we run now means? No, we cannot run. We cannot run because this is not portable. Oracle style means it is not portable. You cannot run Oracle style query in another relational database management software. So to get portability feature, we have to use which style? ANSI style. So now the same example, instead of writing giant query in Oracle style, we want to write in the ANSI style now. Same example I'm taking. This is Oracle. And this one is the SQL Server. This one is the SQL Server. So we are writing one giant query here. We are writing one giant query. This circle representing giant query. This giant query we are writing in ANSI style. This giant query we are writing in ANSI style. So the same query we want to move to the SQL Server and we want to run now. So we are moving this giant query to the SQL Server and we want to run here. So this is the giant query written in ANSI style. We are moving to the SQL Server and we are trying to run. Can we run means? Yes, we can run. We can run. Okay, this feature we are calling as portable. The query written in one relational database management software, you can run in any relational database management software. So to get this portable feature, which style we have to use? ANSI style. If we use ANSI style, you can run in other database management softwares also. If we use Oracle style, in Oracle only we can run. Okay. So giant query we can write in how many styles? 2 styles. What are those? Oracle style, ANSI style. Okay. Which one is the best way? ANSI style is the best way. Why? Because we are getting portable feature. In other relational database management softwares, we can run. Is this part clear? Then how to write in ANSI style? So to write in ANSI style, you remember these 2 points easily you can write. Observe here, just now we have written this Oracle style. This is what Oracle style is. This one is Oracle style. Our requirement is we want to display employee records along with department details. This is the question. So for this, just now we have written this query. This is which style? This is which style? Oracle style. In Oracle style we have written. Okay. Now the same query I want to write in the ANSI style now. So to write in the ANSI style, we have to remember these 2 points. If you remember these 2 points, easily you can write in ANSI style. So first one is observe here in the from class, we are specifying the table names. EMP is one table, department is another table. To separate these 2 tables, what we are using here? Comma. Once again, I'm repeating. in the from class, we are specifying the table names here. EMP is one table, department is another table. To separate these two tables, what we are using? Comma we are using. So in Oracle style, we use comma, whereas in ANSI style, we write some keyword here. To separate two table names, use one keyword. In ANSI style, to separate two table names, use keyword. Use one keyword. Whereas in Oracle style, we use comma. In Oracle style, what we are using? Comma we are using. In Oracle style, we are using comma. To separate two tables, we are using comma here. Whereas in ANSI style, to separate two table names, we have to use one keyword. For inner gen, we use inner gen keyword. Equigen can be also called as inner gen. Equigen can be also called as inner gen. For inner gen, we use inner gen keyword. Or you can use gen keyword also. Okay. Next. Here E dot department number equals to D dot department number is what? We are calling this as the gen condition. This gen condition, in which class we are writing? In the where class, we are writing this gen condition. So instead of writing gen condition in the where class, we write gen condition in on class or using class in ANSI style. So in ANSI style, write gen condition in on class or using class. In on class or using class. Whereas in Oracle style, we write gen condition in where class. So these are the two differences we have to understand. Then we can write in ANSI style very easily. So what are the two differences here? In ANSI style, to separate two table names, what we use? Keyword. In Oracle style, we use comma. In ANSI style, where we are writing gen condition in the on class or using class. Whereas in Oracle style, we are writing gen condition in the where class. That's it. These two differences we need to understand. Okay. So now, this is Oracle style. This Oracle style, I'm changing to the ANSI style. Observe now. This is the Oracle style. I want to change to the ANSI style now. ANSI style. Okay. Now what we have to write here? See, in the from class, in the ANSI style, to separate two tables, instead of using comma, we have to use one keyword. For inner gen, for equigen, which keyword we have to use? Inner gen. Or simply gen also you can write. You can write gen or inner gen. Anyone you can write. Okay. And this is what gen condition, right? This gen condition, where we have to write? In the on class. That's it. This is ANSI style. And this gen condition we can write in on class or using class also. Okay. So now I want to use using class now. To use the using class, we write like this. So to separate two table names, we are using inner gen. Instead of using on class here, we are using class. If we use using class, the advantage is we have no need to write lengthy gen condition here. Here department number is common column or not. So no need to write for two times. Just specify only once. That's it. So this is using class. But in on and using, which one is the best way, sir? This using on is the best way. So using on is the best way. Why, sir? Because listen, For our convenience purpose, we are writing like this. Implicitly, this using department number will be converted to the on e dot department number equals to d dot department number. For our convenience purpose, we are writing like this, but implicitly it will be converted to the on clause only. On clause will be rewritten here. So here we are submitting this one, conversion is required. But here explicitly we are telling, so conversion is not required, directly it executes. So this one gets executed faster than second one. So in the on clause and in the using clause, which one is the best way? Using on clause is the best way. Okay, then why we use using, sir? Just the only advantage we are getting is this Jan condition. We have no need to write lengthy Jan condition. Simply we are writing column name only once. That is the only advantage we are getting. But this implicitly, this using will be converted to the on clause only. Okay, so that's why which one is the best way? Using on clause is the best way. So remaining examples, I use on only. I will not use using. And one more problem is there. That is, common column name must be same here. For example, in the EMP table, department number column name is department number. In the department table, department number column name is DNO. So now in the EMP table, what is the department number column name? Department number. In the department table, what is the department number column name? DNO. So if you write using department number, now it gives error. You cannot write like this. Okay, it cannot convert this to the on clause now. Okay, so because you are specifying column name only once. You are specifying column name only once means column name must be same here. If column name is different, you cannot use using. For example, in the EMP table, DEPTNO, in the department table, DNO you are taking. So in such type of situations, you cannot use using. If you use this on clause, you can write like this. E dot department number equals to D dot DNO, you can write. But whereas if you use using, common column name must be same. So in case of using, common column name must be same. Otherwise, it is not possible. That's it. Now you know very clearly about equijan. Equijan is over. Let me show this ANSI style I'm showing now. Observe. So previously we have written like this. This is which style? Oracle style. Comma is there means you can understand that Oracle. Comma is there and in the where clause Jan condition is there means you can understand that this is Oracle style. In ANSI style we want to write now. So what we have write? Select E dot E name comma E dot salary comma D dot D name comma D dot location from EMP E. Okay, in the Oracle style, what we are writing? EMP E comma department D. But we want to use ANSI style. In the ANSI style, to separate two table names, we use keyword. Which keyword we have to use here? Inner Jan, or simply you can write Jan also. Jan also you can write, inner Jan also you can write. And where we write Jan condition? In the on clause. What is the Jan condition here? E dot department number equals to D dot department number. Observe here, same result it is giving. Observe. Smith is working in research department. Alan Ward are working in sales department. Employee details along with department details it is giving. From two tables, it is giving the data. Okay. Now the same query we can also write by using clause also. So instead of writing on clause here, what we are writing now? Using. What is the common column name here? Department number. Observe here what it is giving. See, same result we are getting. Smith is working in research department. Allen and Ward are working in sales department. So you can use using clause or you can also use on clause. Among this, which one is the best way? Using on is the best way. Why? Because implicitly using will be converted to the on class only and common column name must be same here. Okay, that's it. This is ANSI style. ANSI style is over. Equigen, some more examples I'm taking. Our requirement is display the employee records who are working in Chicago. We want to display the employee records who are working in the Chicago. This is our requirement. So in Oracle style, we are writing. What we are write? Select E dot E name, comma, E dot salary, comma, D dot D name, comma, D dot location. From which tables? From EMP table. In Oracle style, we are writing EMP E, comma, department D. Where? What is the giant condition? E dot department number equals to D dot department number. If we write like this, all employees records it will give. But what is our requirement? The employees who are working in Chicago we want. So we need to write one more condition here and check the condition. Okay, D dot location is equals to Chicago. So perform join operation based on this. And if location value is Chicago, those records only that has to give. So with this E dot department number equals to D dot department number, with this condition, it performs a join operation. After that, if location value is Chicago, those records only it will give. Okay. So according to this example, this 1002 person is working in Chicago and 1003 person is working in the Chicago. Only these records will be given. Okay. So the same query I want to write in the same query I want to write in ANSI style. So to write in ANSI style, what we have to write? Select E dot E name, E dot salary. So this is Oracle style. To separate two tables, what we have to use? Inner join. Here in the on class, we have to write this one. In the on class, we are writing joining condition and write this condition in the where class. In the on class, we are writing join condition, and in the where class, we are writing the condition. If you want to write the same condition in the on class also you can write, but here flexibility is there. You can write like this also. So this is ANSI style. Okay, both I'm running here. Observe. So select E dot E name, comma, E dot salary, comma, D dot D name, comma, D dot location from EMP E, comma, department D, where E dot department number equals to D dot department number. If we write like this, it gives all employees records. Our requirement is the employees who are working in Chicago we want. So write D dot location equals to and D dot location equals to Chicago. Okay, observe now the employees who are working in Chicago only it is giving. Observe. Only 6 employees records it is giving. All 6 employees are working in Chicago. See. So like this, we can write the condition. The same query we want to write in ANSI style. So specify the column list. Then what we have to write? From EMPE inner join department D on E dot department number equals to D dot department number where D dot location equals to Chicago. That's it. So observe here, same result it is giving. Observe. So this is ANSI style. So in the ANSI style, in the on class we write giant condition, in the where class we write the condition. Okay. Next, our requirement is we want to display Blake record. So employee name is Blake. We want to display Blake record along with the department details. So display Blake record along with department details. In which department he is working, his department details we want. What we have tried? In Oracle style. Oracle style we are writing select E dot E name, comma E dot salary, comma D dot D name, comma D dot location from EMPE, comma department D, where E dot department number equals to D dot department number. If we write like this, it will give all employees records. Okay, perform join condition using this condition. So perform join operation using this condition. And if employee name is Blake, display that record. Okay, E dot E name. E dot E name equals to Blake. Okay, so like this you can write. The same query we want to write in ANSI style now. In ANSI style we want to write. So what we have write here? So to separate these two table names, what we have write? Inner Jan. Okay, then where, on, in the on clause, we are writing the condition. Okay, then write this condition in the where clause. That's it. Sorry, select spelling mistake is there. That's it. That's it. So these are the two styles. Now let me write these two queries. Observe. So select E dot E name, E dot salary, D dot D name, comma D dot location. Oracle style we are writing. From EMPE, comma department D, where E dot department number equals to D dot department number and E dot E name equals to Blake. Now it displays only Blake record. Observe here. So the employee whose name is Blake, that record only it is given. Next, the same query we want to write in the ANSI style. So to separate two tables, we are writing inner Jan department D on E dot department number equals to D dot department number. Okay, where E dot E name equals to Blake we are giving. Observe here what it is giving. Blake record it is giving. So this is about equijan. Equijan is over. If anyone is asking what is the purpose of Jans means, what you can say? It is used to retrieve data from multiple tables. So based on Jan condition, it performs the Jan operation here. Okay, so what are the types of Jans? Equijan. Equijan can be also called as inner Jan. Second category is outer Jan. In the outer Jan, subtypes are there like left outer, right outer, full outer. Non-equijan, another type, self-Jan, cross-Jan. Cross-Jan can be also called as product Jan or Cartesian Jan. Okay, we can write Jan query in two styles. One is Oracle style, another one is ANSI style. In ANSI style, if we write, we get portability feature. So it's better to write in the ANSI style. So equijan examples are over. In the next session, I cover remaining examples. So tomorrow we discuss about outer Jan. Okay, thank you everyone. See you tomorrow.